So to summarize, we've looked at numbers in octal, hex, and binary, and we've read them into decimal. We've understood them using the more familiar decimal system. Essentially, what we've done is we already know how to convert octal, hex, and binary numbers to decimal. Let's just look at one more example of each. 241.7. We know what those digits are, but what place value are they in? The 1 is in the 1's place value, or 8 to the power of 0. The 4 is in the 8's place value, and the 2, that represents 8 squared, groups of 8 squared, or groups of 64. To the right of the octal point, we just have one value, the 7, and it is in the 8 to the power of -1, or the 8th place. So what value is this in decimal? Well, 2 times 8 to the power of 2 is 128. 4 times 8 to the power of 1 is 32. 1 times 8 to the power of 0 is 1. And 7 times 8 to the power of -1 is 0.875. These are all numbers in base 10, and if I add them together, I get 161.875. So the octal number 241.7 has the decimal equivalent of 161.875. We can use the same analysis on the hex number. We have 40B point D. We just need to remember that A through F are equivalent to the decimal numbers 10 through 15. I like to write these out for myself as a reminder. So I have A through F to represent 10 through 15. So D is equivalent to the decimal number 13, and I'm just writing myself a little note over top to remind myself, and B is equivalent to the decimal number 11. All right, so which place value is each one in? Well, the B, or the 11, is in the 1's place value. The 0, that's in the 16's place value, and the 4 is in the 16 squared, or 256's place value. Following the hex point, we've now got a D, or a 13, in the 16th place value. Doing our multiplication again, let me finish my notation here. I've got 4 times 16 squared. 4 times 256 is 1,024. 0 times 16 to the power of 1, still 0. B, or 11, times 16 to the power of 1 is still 11. And D, 13, times 16 to the power of -1 is 0.8125. Adding up those four numbers, I've just dropped the 0 because it's not going to make a difference in my final. Adding up those numbers, then I get 1035, or 1035.8125 in base 10. So we've converted from hex now to its decimal equivalent. And finally, we'll tackle the binary number, 11010.1. This works in exactly the same way. This first 0, the one to the left of the binary point, is in the 1's place value. The 1 to its left is in the 2's place value. The 0 is in the 4's place value. The 1 is in the 2 to the power of 3, or the 8's place value. And we find the 1, the leftmost 1, in the 16's place value. To the right of the radix point, we have a single digit. It's a 1, so it's in the 1/2, or the half, or the 0.5 place value. Let's do that multiplication to translate the binary value into decimal. 1 times 2 to the power of 4 is 16. 1 times 2 to the power of 3 is 8. 0 times 2 to the power of 4, that's still 0, so I won't include it. 1 times 2 to the power of 1 is just 2. 0 times 2 to the power of 0 is 0, so I'll skip that one as well. And 1 times 2 to the power of negative 1 is 0.5. 16 plus 8 plus 2 plus 0.5 is 26.5. So we can convert from any number system into decimal simply by reading each digit in its appropriate place value.